Welcome to Grateful, where we provide SAT and ACT online one-on-one tutoring to students all around the world. If you'd like to find out how you can be paired up with one of our specially trained Grateful tutors, feel free to reach out. If you feel like these videos are helping you to accomplish your dreams, feel free to smash the thanks button and contribute to the making of these videos. Right now, we're in the October 2021 non-calculator math section, section 3, and let's jump right in. For question 1 here, we're being asked for the solution to this equation. So let's just start by combining like terms. 3k and 2k is 5k. And now if we ask ourselves what's happening to k, it's being multiplied. So we should divide by 5. That gives us k equals 1 on this side after this 5 over 5 canceled out. And any number over itself is equal to 1. So k equals 1, and that's the answer for this question here. Let's go over to number 2 now. We're being asked for the graph of this equation. And the big tip here is when you're graphing exponential equations, you want to use the zero exponent. The zero exponent is a great reference point because anything to the 0 power is 1. So if we take y equals 3 to the x and we try to use the moment when x is 0, that's y equals 3 to the 0, which is 1. So we just found out that when x is 0, y is 1. And we're seeing that on answer choice A. We're not seeing it on answer choice B, so we already know B is wrong. We're not seeing that point on answer choice C. That one's passing through 0 and negative 1, not 0 positive 1. And we're also not seeing it on answer choice D because that one is passing through 0, negative 3. So just by finding out that this equation passes through x equals 0 and y equals 1, that's enough for us to pick answer choice A for number 2. Now we're going to number 3. Here we're being told this is a quadratic, which is a parabola, and we're given a table of x and y values. So when x is negative 1, y is 0. When x is 0, y is negative 4. And when x is 1, y is 0. So let's just go ahead and create a little informal graph to describe this situation. And we're going to put some points on it, 1, 2, 3, 4, 5 in each direction. And so if I plot the point negative 1, 0, 0, negative 4, and 1, 0, we can already see that it's following the shape of this parabola right here. And the only answer choice that looks remotely like that is A for number 3. So now we can go over to question number 4. Question 4 actually has an element of the most common operation you'll find in the SAT math in general, which is the idea of plugging in a point. Believe it or not. You want to be really familiar with this wording. This wording right here says the y value, because when we're talking about f of x, we're talking about y. This is the y value when x equals 2. When x equals 2, y equals 12. So let's plug that in. So y is 12, and this is our y right here. And x is supposed to be 2, so 3 times 2 squared plus 4 times 2 minus c. And in this situation right here, we want to do the exponent before we multiply in the 3. So that would be 3 times 4, which is 12, plus 8 minus c. And we had another 12 right here. So now we can combine like terms. Then we can take away 20 from both sides. Then we can multiply both sides by negative 1. And we have c equals 8, which is A for number 4. Now we're going to question number 5. Okay, so here we have an intimidating looking word problem, a big paragraph, and whether we admit it or not, it sort of rubs people the wrong way when they first see it. But what we can do in order to feel better about this is describe our variables. So x is the number of minutes running. Y, we're being told, is the number of minutes walking. And so if the equation is 11.5x plus 3.5y equals 265, then you can kind of already see that this is the number of minutes walking, the quantity, times the price, the number of kilocalories burned. Let me just go ahead and illustrate that a little bit better. If I have x minutes and then I have 11.5 kilocalories per minute, you know, this one really is a self over 1 because anything's a self over 1, but the dynamic of it is that the minutes are going to cancel with minutes. And if the same thing happens for the 3.5y and we only end up with kilocalories at the end, then it makes sense that the number 265 that this all results in is also the number of kilocalories. So if the person ran for 20 minutes, how many minutes did the person walk? So that basically means that we need to plug into the equation because x is the number of minutes running, so x is going to be 20. And we have the 11.5 right here, and then we have 3.5y equals 265. So we just basically plugged in the x, the number of minutes running, and now we're going to go ahead and solve the equation. 11.5 times 20, which is a little hard to do without a calculator. 11.5 times 2 would be 23. So 11.5 times 20 would be 230. Plus 3.5 times y equals 265. Take away 230 from both sides, and you'll have 3.5y equals 35. And now we have y is equal to 35 over 3.5. And I guess a good non-calculator way to do this would be to multiply the top and the bottom both by 10. So 350 divided by 35, and that is 10, which is why the answer to number 5 is going to be D. So now we're moving to the next question. Number 6 is asking us to simplify this expression here. And that's really a question of keep, change, flip. Because if I have a fraction with something in the numerator and something in the denominator, I'm basically saying that I'm dividing this divided by that. So here we have 6 over x on the top and 18 over 1 on the bottom, because 18 is really 18 over 1. Any number is itself over 1. And so now the keep, change, flip part of this basically says that if I have a over b divided by c over d, then that's the same as a over b times d over c. And so if we had 6 over x divided by 18 over 1, that's the same as 6 over x times 1 over 18. So that's our rule, so we'll highlight that in yellow. And now that we have it looking like this, we can realize that whenever you have the same factor on the top and on the bottom, they cancel. So divide 6 by 6 and 18 by 6, you'll get a 3 here and a 1 here. So the answer right now is 1 over 3x, which is B for number 6. Now we're going over to number 7. So they're asking us, what do we know about the angle BAC? And they use a critical word, which is the word tangent. If you're tangent to a circle, it means two things. Number one, a segment that's tangent is hitting the circle at one point. Number two, at the point where it hits the circle, it forms a right angle with the radius. And that's our critical detail, because what are they asking us about angle BAC? They're asking us what's the measure of the angle, and by definition, that is supposed to be a right angle, which means that the answer to this question is C. That's a 90-degree angle for number 7. Now we're going over to number 8. For number 8, we're remembering the idea that when the SAT or anything talks about f of x is just a fancy way of saying y. So when they tell us f of x equals 0, that basically means just that y is 0. So whereas y equal to 0, that means that we're at 0 on the y-axis, and the function has y equal to 0 when x equals to 3. And that's D for number 8. Now we're on number 9. Here, they're asking us to isolate T. By the way, these are called literal equations whenever you have to sort of get one variable by itself and move everything else essentially out of the way. So the first thing I would want to point out here is that T is part of RT, part of that group there. And RT is also part of this group right here. So we have sort of layers to that onion that we want to peel. So what's happening to that green group right there? It's being multiplied by P. So the opposite of that is to divide by P. That's going to cancel here. It's going to give us A over P on the left is equal to RT plus 1. So now we've got this group, and the T is in there. So what's happening to the purple group? It's being added with 1. So what's the opposite of that? To subtract 1. So now we've got A over P minus 1 equals RT. And we're trying to get T by itself. So what's happening to T? It's being multiplied by R. What's the opposite of that? To divide by R. So we're dividing everything by R. So right now we've got T is equal to A over P over R minus 1 over R. And the rule that I just used there is the rule that says that if I have A plus B over C, that's the same as A over C plus B over C. So when you've got multiple items separated by pluses and minuses in the numerator, you can separate them out with the same denominator. And that's what we did when we went from this to this. We separated it out just like we have in yellow in the upper right there. Now for this piece here, we're going to have to do a keep change flip, and we were talking about that on the last question. A over B divided by C over D is the same as A over B times D over C. So in that situation on the bottom, we have A over P divided by R, which is the same as R over 1. And that's the same as A over P times 1 over R. In other words, it's A over PR. So if we rewrite it that way, we have T equals A over PR minus 1 over R. And that matches answer choice C for number 9. Now we're going over to question 10. 10 is asking us for the volume of a triangular prism. Now, what is a prism? A prism has the same shape on opposite sides, stretched apart like an accordion. And that's exactly what we have here. we have a triangle in the front and a three-dimensional triangle in the back that we don't really see here. We could kind of make the picture more 3D if we want to be fancy about it. We can kind of show that there's a triangle here. And bring it over like that. So we've got it like that. So now, that is perfectly a prism, and the volume of a prism is capital B times H. Capital B, because it's an area. It's not a length like the area of a triangle. So what is it that we're saying? For instance, a cylinder is actually not a prism, but really, for all purposes, it really kind of counts as one. So let's just imagine I take a circular piece of paper, and I lay it on my desk. And I lay another circular piece of paper on my desk, and another one, and I stack them on top of each other. Very quickly, we'll have the shape of a cylinder that fits kind of the concept of what a prism is. And so now the volume of that would be equal to the circle on the bottom multiplied by the distance to the opposite circle. So what is the base of a prism? It's one of those same shapes. So in our situation, this triangle right here is a base, and this triangle right here is a base. And this distance right here is the height. That's, once again, because the base of a prism is one of the two identical faces that are stretched apart from each other, like an accordion. So let's go ahead and find that. The area of the green triangle, well, any triangle is 1/2 times base times height. But for a right triangle in particular, the base and the height are either two of the legs of the non-hypotenuse sides. So I just labeled one of them the base and one of them the height. But 1/2 times base times height is 1/2 times 6 times 6. And the actual height, in terms of prism talk, which is the distance between the two bases, that actual height is 10. And so we can put all that together to get the volume. 6 times 6 is 36. Half of that is 18. Multiplied by 10 is 180. And the answer for number 10 is C. Now we're going to 11. I personally would consider this to be the toughest question on this whole SAT math section, and it's really not that tough. But basically, there are 9 housekeepers. Let's call that the number of housekeepers. And each of them is doing R number of rooms. So if I want the total number of rooms cleaned by housekeepers, that's 9 times R, because there's 9 housekeepers each doing R amount of rooms. And all of that has to come out to the number of rooms that need to be cleaned, which is half of the 180. So let's take that 180 and divide it by 2. So the work of 9 housekeepers each doing R rooms is going to give us the half of 180, the total amount of work being done. So now we just need to get this equation to match one of the given ones, and what we could do is just multiply both sides by 2 to kind of simplify it a little, and that'll give us 2 times 9R equals 180, which, believe it or not, is A for number 11. Question 12 is giving us a graph, and it's telling us that X is the number of paving stones that are being used, and telling us that Y is the area in square feet. So this point right here is therefore telling us that when we have 2 paving stones, better known as pavers, we have an area that equals 8, because this passes through X equals 2 when Y equals 8. X is the number of stones, pavers, and Y is the area. So if 2 pavers has an area of 8, then I can divide both sides by 2. I can divide both sides by 2, and 1 paver must have an area of 4. Now all these pavers are squares. So if I have a square with an area of 4, that area comes from multiplying the length times the width for a rectangle. If it's a square, the length and the width are the same thing, so let's just call them both L. And the area is the length times the width, L times L. So that's L squared. And so 4 equals L squared. Square root of both sides. If L squared equals 4, L equals 2. And we just found out that the side length of one square is 2. And the question asks us the top surface of each stone is a square with a side length of k. What's k? We just figured out the side length was 2, and so that's B for number 12. Now we're going to 13 here. It's giving us a nice little linear equation and asking us which of these equations is the equation of that line. So if we think of it as a y equals mx plus b, b is our y-intercept, which is right here, that's the number 2, and our slope is rise over run as you go from left to right. So let's call this point A, call this point B, and as we go from left to right, from A to B, how much are we rising? We're going down 2. And how much are we running? We're going over 1, 2, 3, 4, 5. So we went down 2 over 5. So the slope is negative 2 over 5 because we're going down, not up, as we go from left to right. So this is the equation of the line, like it or not, and we need to kind of maneuver it into one of these. By the way, those equations, those answer choices, that's called standard form when you have them in the format of ax plus by equals c. So we've got to get this into standard form. And the easiest way to do it, in my opinion, is to go ahead and multiply both sides by 5. That'll give us 5y equals negative 2x plus 10, because when you multiply here, you get 10. When you multiply here, you get negative 2 over 5 times 5 over 1. The 5s would cancel, leaving you only with negative 2. So now we've got it like that. We can just add 2x to both sides, and we'll get 2x plus 5y equals 10, and that's answer choice D for number 13. Here we have 14, and 14 is just a very, very important question for us. And it's called the number of solutions for 2 lines. This is a frequently occurring question, and you need to practice it to the point where you're ready for it when it comes up. It always has the same 3 components. You always have 2 linear equations. The question's always talking about the number of solutions. Here, no solutions. And there's always an extra variable besides x and y. In this case, it's n. But you always see the same earmarks for this, so you want to be really familiar. Once you decide it's a question about the number of solutions for 2 lines, you have to think about how there are 3 ways that 2 lines can intersect, or interact, let's say. They can hit once, they can hit never, or they can hit all the time, if when you go to graph them, you realize that they're actually the same line. Now, if they hit once, that's because the slopes are different. If they hit never, that's because the slopes are the same. The same slope is the reason why they're never hitting. It's the reason why they're parallel. And if they hit all the time, it's because the slopes and the y-intercepts are the same. So here, we're being told that there's no solution, so it's this situation. The slopes are the same. And so, in order to mathematically show that, we need to get both of these equations into a y equals mx plus b format. Then we can just find the 2 slopes, and if they're supposed to be the same, then we can make them the same. We can set them equal. So let's take the first equation, nx plus 3y equals 1. Take away nx from both sides. 3y is negative nx plus 1. Divide both sides by 3. Negative n over 3x plus 1 over 3. And doing it for the other equation, 12x minus 6y equals 0. Take away 12x from both sides and divide by negative 6. You get y equals 2x. So our slopes right now are negative n over 3 and 2. And by definition, those slopes have to be equal, so let's make that happen. Negative n over 3 equals 2. Multiply both sides by 3. Multiply both sides by negative 1. And we have n equals negative 6. And that's B for number 14. Now, a very, very important thing that you should know is that we just discussed level 1 of this question, the number of solutions for 2 lines. But level 2 of this question is one of the hardest things to identify. So you need to kind of study and be ready for that situation when it comes up. It's this exact situation, but instead of giving us the equations this way, what you're going to see is the equations will look something like this. Negative n over 3x plus 1 over 3 equals 2x, and it'll say that has no solution. So now, just backtracking a little, when we get to equations and we get them in the y equals format, like this and like this, if we set those equal, we're basically looking for the intersection of the two functions. Here we didn't do that because we knew that they were never going to intersect. But what I'm saying is that when you have two linears, so what's on this side and what's on this side, those are both linear because they have x to the first power. If they're set equal, it means we're seeing an expression of an intersection. So if the question is given to us this way, what they're basically saying is that when we looked for an intersection to the situation, there was no intersection. And then it'll ask you, what's the value of n based on that? And so then you're supposed to go through the process we just did and separate them out. You're supposed to say this side is equal to a y equals. You're supposed to see them as two separate equations. And this side is equal to a y equals. And from there, it's basically the same problem we just had, where we're going to say, okay, well, there's no solution, so that means the slopes need to be the same, and you set the slopes equal. But it's important to see this question type, the number of solutions of two lines, as, well, question 14 being level 1 of that question type, and the other example I gave in the upper left here being level 2 of that question type. A very, very important question, particularly for people who are interested in getting that score above, let's say, the 1450 or 1500 level. You can't get there without understanding what I was explaining to you on this question. So let's go to number 15 now. 15 is asking us to simplify a radical. And in many situations, you want to separate radicals or exponents. Not always, but there are definitely some situations where it comes in really handy. Because the square root of x times the square root of x is x, but the square root, but the square root of x times the square root of y is the square root of xy. So that second rule can be done backwards. I can say the square root of xy is equal to the square root of x times the square root of y. And that's what we need to do here in order to make this more digestible, believe it or not. So I'm going to say this is the square root of 16 times the square root of a to the 16. The square root of 16 is 4, so we already know the answers could only be a or b because they've got a 4 out front. But another thing we can add to our list of radical and exponent rules is that the square root of a number is the same as that number to the 1/2 power. So we can rewrite this as a to the 16th to the 1/2 power. And although if I have two of the same bases and I multiply, we're adding the exponents, it's also true that if I have a situation like this and we're raising it to a power, we're multiplying the exponents. So we've got a couple more rules that we're going to kind of utilize here. And if we have a to the 16th all to the 1/2, the bottommost rule I have there in yellow says that we should be multiplying, just like we multiply b and c here, we should be multiplying 16 and 1/2. So 16 times 1/2 is 8, and we have the 4 out the front, and that's 4a to the 8th, which is b for number 15. Now we can go to number 16. My screen jumped. That's something that happens a lot in Microsoft OneNote when you zoom in and out on a PDF. In any case, here they're giving us a y equals mx plus b situation. In the m spot is 3/5, and in the b spot is -8. So we know that b, the y-intercept, is -8, and m, the slope, is 3/5, and it's that easy for number 16. Now we're going to 17. Here, they're asking us to find the solution for a system of linear equations. And in general, you want to lean toward the elimination method when you do this. Now, by the way, if they're asking you for x, that means that the easiest thing you can do is to get rid of y, to eliminate y. So let's do that on purpose. Let's multiply this one by 3 and this one by 2. That's going to give us 6y here and -6y here, and we will get rid of y when we do that. So distributing the 3, we'll have 9x plus 6y is 24. So 9x plus 6y is 24. And distributing here, we have 8x minus 6y is 10. So now we can add straight down. 9 plus 8 is 17, and 24 plus 10 is 34. And we can divide both sides by 17, and we'll get 2. And 2 is the answer for question 17. It's the value of x. Going to 18, here we're being told that the sine of x is equal to the cosine of 20. And this is a reference to something, and that's what the SAT is really all about. Everything is a reference to some idea that you're supposed to have been trained on, and that's what our tutors at Gradeful can show you how to do if you're interested in tutoring. But the rule is being referred to, we call it the idea that cofunctions of complementary angles create equal expressions. So cofunctions of complementary angles create equal expressions. So to demonstrate that, if I have the sine of A and the cosine of B as two things, I have sine of A and cosine of B. If A and B are complementary, complementary means that they add to 90, then it can be said that the sine of A is equal to the cosine of B. That's the equal expressions. So we have cofunctions, sine and cosine, complementary, they add up to 90. Therefore, we have equal expressions. The sine of A equals the cosine of B. So now, on the question 18 here, on question 18, we're being told that we have equal expressions because the sine of this already equals the cosine of that. We're also being told that we have cofunctions because we've got sine and cosine. So for this rule, cofunctions, complementary angles, equal expressions, if you have any two of those, you can assume the third to be true. So because we have cofunctions and equal expressions, we can assume the angles are complementary, and so x and the 20 have to add up to 90, which means that x is 70, and that is our answer for number 18. Going over to number 19 now. '19 is another reference to an idea. You're supposed to know that if I have an absolute value equation, it splits into two sides. In this example I'm giving you, a plus b would equal c, and a plus b would equal negative c. So, now first of all, why is that? That's because if I had the absolute value of a positive number, nothing happens. But if I had the absolute value of a negative number, it flips it back into a positive. So when you have an absolute value equal to some number, we don't know if what went inside the absolute value was positive, in which case the number stays the same, Or if the thing that was inside was negative, it would have to be multiplied by -1 to turn into a positive. And that's why when you have an absolute value equation, you're going to have one side where you leave it the same and one side where you set it equal to a negative. If we're an absolute value inequality, on the negative side, you'd also reverse the inequality, but maybe we'll show one of those when one of those questions comes up. So, nice and simple, all we have to do here is just say x minus 2 equals 3, x minus 2 equals -3. Add 2 to both sides on the top one and you'll get 5. Add 2 to both sides on the bottom one, you get -1. So the answers are 5 and -1. What's the sum of those answers? Just add the 5 and the -1 and you'll get 4. And that is our answer for number 19. Now we're going to question 20. 20 is telling us the sum of the solutions of this equation is 5. So let's just bring in the quadratic sequence real quick, just as a separate example. Let's say we had y equals x squared minus 2x minus 35, and the question said find the x-intercepts. The x-intercepts of any situation are the moments when y is 0. So 0 equals x squared minus 2x minus 35. Then you can factor. Having it equal to 0 is your permission to use factoring, in this case BC factoring. The two numbers that add to -2 and multiply to -37 are -7 and 5. And then the zero product rule says that if those two parentheses are multiplying out to 0, you can set each individual one equal to 0. And you can solve each one now, so we'll add 7 to both sides and take away 5 from both sides. And more important than any of this is the terminology. At this top stage, these are called the factors. And at this bottom stage, these things are called roots, x-intercepts, solutions, and zeros. And so, when we're hearing about the solutions of a similar equation, this one's not quadratic because it actually has 4 x's, but the zero product rule, where we took these two things and said, well, if those two are multiplying out to 0, then you can set each one equal to 0. That holds true here as well. Here, the zero product rule would tell us that this thing times this thing times this thing equals 0. Therefore, each one should be set equal to 0. And so, here we're going to take the square root of both sides and just get x equals 0. Here we're going to take away 3 from both sides, so -3. And here we can add b to both sides, so x equals b. So our three solutions are 0, -3, and +b. The question is telling us the sum of those solutions is 5. So 0 minus 3 plus b equals 5. Add 3 to both sides, b equals 8. And that's our answer. We're done. Thanks so much for listening to our October 2021 non-calculator math explanation for the answers of Section 3 of that SAT. Gradeful provides one-on-one online tutoring to students all around the world. If you're interested in being paired up with a Gradeful tutor, reach out. You can find our contact information in the About section of our YouTube page. And if you feel like these explanations are helping you to achieve your dreams, feel free to smash the thanks button and contribute to the production of these videos. Thanks so much, and have a great day.